So next up we have Jim Kuiper. Jim Kuiper is the head of operations at ActiveStream, and he's going to talk to us about the 200,000 odd smart meter devices he's been deploying across Australia.
Thank you. Well, thanks everyone. It's really exciting to be here and to listen to everybody talking about all the ins and outs of how they see the IoT world. We hear about, all the huge range of stuff that GE does. I always find it fascinating. I used to work at GE, and the sheer breadth of the business amazes me. And then we've heard Paul talking about how IoT is the interface between the digital and the technical world. And so it feels to me like a good opportunity to talk about the business that we've built at ActiveStream, which is, I guess, our own little version of an IoT business. And it's the way those factors come together in one corner of the energy space in digital metering. It's not a bad sized business. As at this morning, we had 217,966 metres on the wall and reporting data every day. So I can talk to you a little bit about the journey, about how we built the business case to build ActiveStream and the sort of things that we did to get it off the ground, and then what's been important for us in making that story into a reality. So we'll start with the history. Up until pretty recently, all of the electricity meters in Australia were of the old spinning disc variety. So they used the principles of electromagnetism to spin this physical disc that would record energy usage. And then after a while that started to turn into electronic meters, but the principle was still the same, that they would measure the amount of electricity that you used, and then somebody would come around to those meters every 3 months, record the data on the meter and take that back so that your electricity retailer could send you a bill. The first major change to that philosophy kicked off in 2009, where Victoria mandated a rollout of smart meters across the entire state, and that concluded in 2015. And then on the 1st of December this year, what we think of as the new world of digital metering commences. And this is instead of a network-led rollout, which is what happened in Victoria, this is going to be led by retailers and by competitive metering market providers, of which Active, and then you get charged by the distribution network, something like 100 largest. It was initially driven by the notion that digital metering, real-time metering consumption information could give consumers control over the way that they used energy, and that would let people charge critical peak prices when, as Paul showed you, the air conditioners are all running on a particular day. It turns out that retailers are really quite unwilling to slug people with 10 times the energy price when it's Christmas Day and everybody's in the house. So it begs a question: how did we put the business case together to launch ActiveStream? And because it's a retailer-led rollout, we don't operate like the distribution networks on the basis of regulated revenue. We had to build a justification that was based on business principles that are probably more familiar to people. And so you either build a business case by bringing more money in the door or by stopping money from going out the door. And so those were the fundamental elements of the business case. The question was, could AGL, which is ActiveStream's parent, could AGL win more customers through digital metering-driven retail propositions? Could they do things with the metering data that would let them win more customers in the market? And then on the other side, how can you stop money going out the door? So, for example, if somebody needs to be disconnected because they've moved out of a house or because they haven't paid their bill, in the old world, you send somebody to the site and that person actually physically removes the fuse, and then you get charged by the distribution network, something like $100 a shot. Obviously, being able to simply press a button in the control center and do that automatically saves quite a bit of money. So there was a lot of investigation of that, and as I said, we've deployed quite a lot of meters, but the thing that's really driving it now is compliance. So with the new regulations coming in, all new meters from the 1st of December need to be digital meters. So if you're building a new house, if you're upgrading your meter, or if your old meter needs to be replaced, it's got to be a digital one. So how do we play in this space? The service that we provide, a lot of people think about metering as being a hardware business, or depending on how you come at it, as a sort of software business or a data manipulation business. We think of ourselves as a data service business. So we provide data every day. So for every single one of our meters, we have an obligation to provide data to the electricity market operator every day. We collect the data in 30-minute intervals that we read 4 times every day. There's also some off-market data that we provide. So some AGL customers get a data feed from us showing what their solar production is, and we collect that data every 5 minutes and we deliver it every 15 minutes. And so it's possible, depending on how you configure the system, to play with those parameters and report more frequently or collect different types of data. So engineering data, for example, can be provided to distribution networks to allow them to monitor things like voltage, power factor. To the extent that it makes sense for them, it can be used to allow them to moderate their capital building programs, but that's often more attractive in theory than it is in practice. And then how do we do what we do? So if the data service is what we provide, what are the ingredients for that? And as I think of ActiveStream, I think what we fundamentally are is an infrastructure business. We're not an IT business, we're not really an IoT business, we're an infrastructure business. And the 4 elements of that are, we're able to get the assets out there, we're able to create and maintain an IoT connection across a couple of 100,000 assets. We're able to bring the data back, manipulate the data as we need to, and publish the data. And then we're able to manage the asset over its life cycle. So obviously, there's a fair chunk of cost that goes in getting the meter out there. If you have to visit the meter halfway through its life, if it's a $500 installation and it costs you $100 to do a site visit, that obviously has an immense impact on the economics of the entire deployment. So our asset management is actually a really key part of what we do. We store lots of photos of the meter board, for example. We store information about exactly what the serial number of the modem is, of what class of antenna is at the site, what exact version of firmware is on the meter and on the modem, because all of these things can allow us to do remote diagnostics of the site, and that could potentially save a truck roll. And the thing that we like about this cluster of skills is that these are all the skills that you need to do really any distributed infrastructure IoT deployment. So we always thought of it as a distributed energy business or a distributed infrastructure business, of which metering was really just the first product. So if you're deploying connected batteries, all of the stuff that Paul likes to talk about, if you're talking about connected batteries, remotely monitored solar panels, if you're talking about remotely read gas metering or remotely read water metering, all of these things require that same 4 sets of capability. You have to be able to deploy, that has to be safe, has to be on time, has to be on budget, and you need to have a good customer experience, which primarily means, by the way, showing up when you say you will. You need to be able to create and keep the connection open to your devices, you need to be able to report the data, and you need to be able to minimise lifecycle cost. And so as I look at what's really critical to the business, the 4 things that came to mind for me were safety, and safety is absolutely crucial. And it's amazing as you visit hundreds and hundreds of thousands of sites, the incredible things that happen. The 2 most serious injuries that we've had out of 217,000 metres deployed were one tech had brought his wife on site as a technical assistant. She put a foot in a rabbit hole and fell and broke her arm. Then there was another guy who pricked his finger on a bougainvillea bush, got a streptococcus infection in the tip of his finger, and 3 days later he ended up having the tip of his finger taken off. This is why we have such an intense focus on safety in the business, because all this kind of stuff can happen. Turning up when we say we will turns out to be quite possibly the most important single thing that we do from the point of view of our customers, the electricity retailers. Turning up late has the biggest impact on customer satisfaction of everything else put together. Cost is critical, because billing data is billing data is billing data. It's pretty hard to differentiate. And then customer experience, which is pretty much turning up on time. So as a bit of an example, I thought I might talk about the differences in some of the deployments that we've done, because it turns out, and this will probably come as a surprise to nobody who's worked in telecommunications, that working in metropolitan Australia is a completely different business model from working out in the bush. And we found this as we worked through the solar bonus scheme in New South Wales that wrapped up at the end of last year. So this was for those of you who aren't familiar with the energy sector, the New South Wales government paid an extremely generous solar feed-in tariff that required gross metering. This means that the metering was configured to measure everything that was exported to the grid. And then when that tariff came to an end, all of the people who were on that tariff were suddenly going to lose money if they didn't have their metering changed over. So we suddenly had 20,000 customers, more than 20,000, across all of New South Wales who had to have their metering changed over, and it needed to be done by the 31st of December. So we kicked off this program to do it. And so I pulled a couple of examples from different parts of the country to show just how different the business can be in different areas. So the map on the left, you probably can't see enough to realise where that is, but that's out in Western Sydney. We picked 800 metres that we visited in Western Sydney. And what you'll notice from that is that you could, it's about 6 or 7 kilometres from one end of that patch to the other. So you could start at one end of that map and walk to the other in less than an hour. And that has an obvious and predictable impact on the economics of doing the deployment. The second map is exactly the same number of sites, but spread over probably a quarter of regional New South Wales. So it's actually closer to 700 kilometres from one end of that deployment to the other. So if you got in a car and drove at full speed on the highway all day, it'd take you all day to get from one end of that area to the other. But the same number of metres, right? Same number of metres. So we learned a great deal out of doing that case study, because the differences in how you approach something like that affect almost everything that you do. So the relationship with the customer, with the retailer, needs to be different. The relationship with the field service provider needs to be completely different. The contractual arrangements that you have with both of them need to be appropriate to the kind of work that you're doing, right? So for example, if you have a meter tech in the city, you can pay him less than $10 if he turns up at a site and can't go ahead with the installation. If you've got somebody who's out the back of Dubbo and he's got to drive an hour and a half to get to his next job, and there's a chance that he's going to get there and not be able to get a signal, and then he's going to have to abort the job, if you only pay him $9 for that abort, he's just not going to go, and you're not going to get the job done. So you need to change all of those commercial parameters. The way that we talk to customers, the way that we took appointments, all of those things needed to change. We ended up working with different field service providers on broadly very different terms to operate in the different areas. Our specific IoT strategy, as you can imagine, was very different. So the hardware that we had to use was different. The modems were the same, but the hardware had to be different because the choice of antenna and when we deployed which antenna and at which stage of the deployment process we did that had to change as we went from different areas. And so even downtown Dubbo to maybe 50 k's out of town to beyond 50 k's out of town, we would have different work instructions and different processes that we expected our techs to follow in order to have the best chance of being able to get a connection with the least cost hardware. And then finally, we found that we needed different quality management strategies and different safety strategies in order to economically being able to manage those sites. So for example, in the city, you can simply drive around and somebody might be able to audit 20 or 30 sites in the course of a day. When you're out in the bush, you need to think about who's going to be doing that auditing, because if they've got an hour to drive between sites, you're just not going to get enough out of them in order to be able to make it all make sense. So I suppose the takeaway is that of all the things that make up our IoT business, it was actually the ones that were closest to the customer impact, which made the biggest difference in getting business off the ground and in terms of making the business viable in the long run. So, how effectively could we deploy? Could we get there when we said that we were going to get there? Were we able to continue to establish and then continue to deliver a data connection once we got to the site? I guess that's a little bit of a summary of how we've been operating. We're going to be moving into the new world starting the 1st of December, so you'll probably start to hear more about smart meters, and I certainly hope that it's more positive than the last time somebody did a smart meter deployment. So with that, thank you very much.